Right, I hope you can hear me now. So let me just start over again. Hello, Selim, can you hear me?
Yes, I can hear you.
Okay, let me start again. Let me start from what my analogy for functions. I said imagine you have a robot and you every day you code your robot to get you some milk from the store. This is the store right here. This is your robot. So every day you write the same code that is telling the robot how to get to the store, and then telling the robot to get you a glass of milk. So this is your code here. You write move right, move up, move right, and buy milk. So every single day you code your robot to get you some milk every day. So this is why we need a function. Function is used to wrap your block of code, to wrap it in a function, to give it a functionality, and then to use it some other time, like to reference the function some other time if you need to use it. Like your robots, the way you write your robot every day to move right, move up, move right, buy milk every day, you can just simply write a function for it and then just supply your robots the function every single day. So your robot can go and get the milk for you. So you don't need to write that same functionality of moving right, moving up, and everything every single day. Since you have your function, you can write the functionality in the function, the implementation in the function, and then you can supply your robots the function. So your robots will now know, oh, this is what I'm meant to do. Every day you just supply the function to the robots. So that's why we need functions to modularize your code, to avoid repetition, because we call something dry. Do not repeat yourself. So programmers, you are meant to be lazy, not the lazy you are thinking about. We are talking about um, cleverly lazy. So you are lazy in a clever way. So instead of writing the same functionality every single day, just package it in the block of code and package it in the function that you can reuse every time you need to use it. So basically, function is just for reusability. So you should be able to reuse your code. So that's why we have function. So everything I've explained, we'll write it in code now. So now I mentioned that in that. Let me zoom in. Hold on. I mentioned that in that every code you write should be in your main function, because your main too is a function. So your main is like an entry point to your app in that. So anything that is not in your main function, that will not bother running it. So it runs only the code inside your main function. So let's say we want to write the function for our robots. Hold on, before I do that, let's say this is the functionality. Every day you want to tell your robot to go and get you some milk. You write move up, move left. Let's say move up again. So imagine you have a lot of functionality that you need to tell your robot. So every day you need to write that same functionality. It will be redundant. So you don't need to write it over and over again. You can just write it in a function. I just say buy milk. So let's say this is what you tell your robot to do: to move up, move left, move up, buy milk. So imagine if you are writing this same code every single day. So it's all called for. So you can just simply write a function. Let's name it get milk. So let's take this block of code and put it in our function. And print. Yeah, we are printing the functionality here. Just imagine that this is just like another function for the robot to move to wherever it wants to move to. So you can still follow the functionality. So we can run our code. Like I said, if we run our code right now, to run our code, we have to type that run, the name of the file, functions.dat. So if we run this code now, it's not going to print out anything. It's not going to run. Why? Because I said any code you write has to be in your main function. So we've written our code, our functionality for the robot to get the milk. Now, this is not the end of the code. So what we need to do after writing the function, we can call the function anytime we like in our main function. So to call a function or to invoke a function, you type the name of the function followed by your parentheses, and then now we can run it. So you can see sprinting, move up, move left, and all that. So we are calling the function here. We are invoking the function here, and to call a function, you need the parentheses. It's mandatory. Imagine we do away with the parentheses. Let me run the code again. It's not going to print. It's not going to run the function. So the function is just there. You are not calling. You are not invoking the function. You are just typing the name. That's why it's not printing it here. So to invoke the function, you need the parentheses. So now this is function declaration. You are declaring the function, and you are writing the logic here in the block. So the block starts from the opening parentheses, followed by the opening curly brace and the closing curly brace rather. So you have to write the functionality inside the block. So this is a block now. So now we can call the function anytime we like. So we can call it 4 times, 5 times, anytime you like, or anywhere in your code that needs the function. So now let's print. You can see it's printing. We have a lot of print statements here. From here, move up from here to here. That's the first call, the first invocation. So you can see we are invoking it 4 times. That's why we are having a lot of print statements here. So now we can declare our function, and then we can call it. Now imagine to declare our function, we use this void keyword. What this void keyword is saying is that this function is not returning anything. Again, let me come again. This function is not returning anything. To declare a function, you use the function name. Let's kind of break this function down a little bit. To declare a function, you use the function name followed by your parentheses, and then the curly braces, which is the block for the code. That's where you write the code. So now, the other thing I didn't mention before was the return type of the function. Your function can return something or nothing. If the function is returning anything, the return type is going to be the type of the return statement of the function. So imagine, let's say this function is going to return, let's just see, gotten milk. So it's giving us an error because the return type is of type void. So here, I said the return type here has to match with what we are returning here. So obviously this is a string. So if you are returning a string, we use string. So you are saying get milk is going to return a string. That's why we are using return here. But initially, we don't use the return statement. So if you are not using any return statement, if you are not returning anything from your function, you use void. So it's important. If you don't use the void, it's going to be returning null, for instance. If you are not using void here, see, it's returning dynamic, and in runtime, it's basically null. So just use void to tell it you are not returning anything. So you can see the return type of the function is void. So yeah, still following the analogy. Let's say, okay, every day, hold on. Still following our robot analogy. Yeah. Why is this thing like this? All right, let's say you you tell your robots to go to the store to get milk for you. Now, you want to tell your robots, every day you tell your robots, go get me a glass of milk, right? So now you want to change the functionality now. It depends on how you are feeling that day. You don't know, maybe you might have visitors that need milk that day. So you can now tell the robot that today I want you to get so amount of glasses of milk. So you can tell the robot each day that I want 1 glass of milk, I want 2 glasses of milk, just like that every day. So to do that, to code that in our function and this thing now, you can tell the robots that I want, you have to specify the type. Let's say count. Let's do it with this one now. So now you are specifying, so anytime you call the function, you are specifying the amount of, I hope I'm recording this session. Right. So every time I'm sending the robot to get me a glass of milk. Now I can supply to the robot that I want this amount of glasses of milk. So I can supply any amount I want here. Let's say, let's just print gotten count glasses of milk. So now every time I want to call the function, I have to supply the function how many glasses of milk I want. So let's say we are calling get milk now. We have to supply. See, it's not allowing us to call the function. He's giving us an error because it's expecting the amount of glasses of milk I want. Let's say we want 6. I had a lot of visitors that day. So I'm telling the robot, get me 6 glasses of milk. So let's run this code now. So you can see, gotten 6 glasses of milk. So it depends on how much, let's say another day, I just want 2. You are lactose intolerant, sorry. So you can see telling me gotten 6 glasses. That's the first invocation. And the second one too, I'm supplying 2 to see. Gotten 2 glasses of milk. So now our function is kind of dynamic if you think about it. So if we want to call our function, we can supply to the function how much milk we want depending on that day. So you can see where I'm going with this. For instance, let me think of another example to use for you in the return statement. Okay, I wrote another function for them the other time. Let's do it with this get milk function. Let's write a function that returns a greeting. So this greeting should be of type string. So the return type is string, the name of the function greeting, then the parenthesis, then the block. So in the block, let's say it also expects to pass the name. So if you call the function, you are to supply your name, your own name to the function. So let's see what this function just does is it returns a greeting that says hello, and then the name. How are you doing? All right, so hold on. So it's going to return this string basically. So you are supplying your name to the function, but in the function we are using the name, and it's returning this string. It's returning hello, the name you supply to it, and then how are you doing? Now to call this function, we can just basically call greeting, and then let me supply Celine to it. I hope I've not lost you guys.
No, we can hear you.
All right. So let's so we are calling the function now, and we are supplying a name to it. We are giving it a name. So if we run this, it shouldn't print out anything. As you can see, it's not printing out anything because this is basically, remember that the other time we were using a print statement to print something out in the terminal. But here we are basically returning this value, this string. So once we are returning it here, so this function is returning something, right? And we are not using it. So if we are returning something from a function, we need a way to capture it. We need to capture it so we can reuse it. So to capture whatever this function is returning, let's store it in a variable. Let's say var greet is equals to whatever greeting is returning. Don't get confused though. Now, if we check the type of greet, you can see is a string because this greeting function is going to return a string. I remember I talked about type inference, that if you are using the var keyword, that is going to infer the type from the right hand side. So whatever the right hand side is evaluating to. So it's basically the same thing. I just saying, sorry, I just saying Selim here. Here, if I see Selim here, you know, greeting is greet is Selim, and is of type string, right? If you check, is of type string. If I used an integer, it becomes type int, right? Like I've mentioned in the previous classes. So greeting is returning a string. Remember, it's returning a string, and we have to capture it. If we don't capture it, it's just going to be floating around the memory. So we are capturing it in this variable called greet. So now we can now print whatever the value of greet is. So now we can print greet, as you can see, saying, hello Selim, how are you doing? So greet is holding whatever value this greeting function is returning. I hope you can follow. This greeting function here is returning this string hello name. This name is whatever you supply to it. Remember here, that's supplying Selim. So just think about it like this. This name is like a new variable. It's like saying, sorry, string name is equals to Selim. So this statement here is the same thing as this. So we are supplying Selim to it here. Here. So now, anytime we call greeting, so we have to supply a string, a name to it. There you get. So we can use that variable name in the body, in the function body. I hope you can get why we need a parameter now. So that's what we call this thing. This thing inside the parentheses is what we call parameter. But when we are calling it here, this one is an argument. So you get, it's just technicality. What developers call it. They use it interchangeably. They use parameter argument interchangeably. You don't have to worry about that. Just know that you need to supply when you are declaring the function. This is a parameter. We are supplying it a parameter called name, which is a string. And then when we are invoking it, we are now supplying it with the argument, which is Selim. I hope you can get it now. So that's just like I see a run through of what function is. So there is another way we can declare a function. If you have a return type here, you see, if you have a return type here, you know I said it should be inside these curly braces, right? Like this is a block of code. But if you have a return type, we can basically just change it to a one-liner. So just make it in a one line. Sorry, in one line rather. So you can do away with the curly braces. You can do away with the return keyword, and then we use something we call arrow function. So this is the same thing as what we had before. Hold on. So this was what we had before, and this is what we have now. This is giving me an issue because we are using the same name. Remember, I said we can't use the same name. Which one do you want that to call whenever you are invoking? Okay, for now, let's just say greetings. All right. So this is the same thing. These functions, they are basically doing the same thing. So here is just for one line. You know, we got rid of the return keyword here. So we call this implicit return. It's implicitly returning this string. So as you can see, it's returning this string. We don't need to use the return keyword, and we use this arrow function. So my own is looking like an arrow because I have ligature turned on. So your own should look something like this. It should be, but without the space. It should be something like equal to sign and then greater than sign. So you should have an arrow function. So they are basically doing the same thing. I hope you can follow. How about I've not lost you guys? Hello.
No, we can hear you.
All right.
No.
All right. Oh, Miss Treasure, I didn't know you joined. I hope you've not missed a lot. I hope you joined in time.
I think I missed a lot already, but you can go ahead. I'll
Right.
catch up.
All right, I'm recording
Thank
the session, so don't worry. I'm just with the
Oh,
session.
thank you very
No
much.
problem. So let's just like in the last class, I wrote a program. Hold on. To calculate. So if you need a function to just get the max of two numbers. Sorry. Let's say we have a function. Let's create a function called okay, I want it to return it. Called max. It takes in two integers, int a and int b. So what this function should do, what I want this function should do is it should take in two integer numbers and it should check which one is the largest in the two integer numbers, and then it should return the largest of those things. I hope you can get it. It should take two numbers. Let's say it's taking 1 and 2. Then it should return the largest, which is 2. The largest in the two, between the two is 2. So it should return number 2. So that's what this function should do. So anytime we want to check which of two numbers is the largest, we can use this function. Let's say we check if A is greater than B, then I want it to return A. That means, you know, if A is greater than B, right? If you're not in the class where we were talking about if statements, this is like, we call it a control flow. If statement takes in a Boolean expression, an expression that evaluates to either true or false, and then it checks if that expression is true, it runs the block of code inside. But if it is not true, it does not bother entering this block of code. You know, I said the block of code is like from this opening curly brace to this closing curly brace. That's a block of code. So it checks if this Boolean expression is true. If it is true, it enters here. But if it is false, it does not enter. It goes on to the next statement. So now we know now if A is not greater than B, that means A is smaller, right? That means B is greater. Then we can use the else. Else is like a catch-all block. So if this one is not true, then it goes to the else statement. Now here we can return B. So let me come again. So this max, what this max function is meant to do is it takes in two integer numbers. It checks which one is the largest, and then it returns that one. It returns the largest number. So here we are checking if A, you know, we are supplying the two numbers. We are supplying A and B. So we are checking. I'm sorry if my voice is a little bit muffled. I have kata. Sorry, I'm not feeling fine. So we are checking if A is greater than B. Remember, when we talked about relational operators, whenever you use relational operators like greater than, less than, equal to, and all that, those expressions evaluate to Boolean. So you can remember. So here we are checking if A is greater than B. So if it evaluates this value, it checks, oh, A is greater than B. Now, if it returns A, it does not bother entering this else block. It does not bother running this else block. But then it checks if A is greater than, but if A is not greater than B, you know, we are using it here. It checks A is not greater than B. Oh, it gets away. It does not bother entering this block. Then it enters the else block. because in the else, it's just the same thing as checking else if B is greater than A. This is the same thing. You get? It's the same thing. We are checking else if B is greater than A, then return B, right? But since we have the else statement, else is like a catch-all. That means we know the how do I put it? The other I'm looking for the word, but don't worry. We are checking if A is greater than B. If it is true, right? True one's this one. But if it is false, that means B is greater than A. That's why we're using else here. Now it's returning B. So now we want to use the function. It's returning something. So we have to capture it. We have to capture whatever is returning. We have to capture it in the variable. Let's say var n is equals to max. So max is expecting two integer numbers. Let's say 34, and then the second integer number, let's say 50. So visually, you should know that n is going to evaluate to 50, because that's what we wrote in the function. We said that it should return the highest, the largest number. So if we run this code now, sorry, we are not printing it. Let's print whatever n is. So if we run this code now, it's going to run var n. It's creating a variable in memory. It's creating a storage in memory. It names it n. You now say, you are assigning a function to n. Now before it gets assigned, it runs this function, because this function is going to return something. Remember I said if it's not going to return anything, we use the void keyword, right? But if we are using void, we are not supposed to use the return keyword. Now, if you use void here, see, max is void, right? It's not returning anything. That's why you cannot print n here, because it is of type void. That means you are telling that print nothing for me. So it's not going to allow. The expression has a type of void, so its value can't be used. So you can see. So that's why here we are returning an integer here. We're returning the largest. So when we run the code, it's going to store a variable n. Before it stores this value, it checks this function. Then it enters the function. Integer a. This is the function, right? The function declaration. Int a. Now it assigns 34 to a. Just like when we said var n. It assigns 34 to a. The second parameter b, it assigns 50 to b. So now it's going to run. Now, is 34 greater than 50? Oh no, it's not going to enter here. It's going to enter the else block. That means 50 is greater, right? Now it's going to return b. So let's print. So it's returning 50, right? It's still the same thing. We said 50 here. Our time is almost over. 34 here. So it's going to supply 50 to A, right? If 50 is A, 34 is B here. Now it checks, is 50 greater than 34? Oh yeah, it is true. So this expression is evaluating to true. Now it returns A. It's not going to bother running this else block. Something I didn't mention. Once you return something here, you cannot later write a block of, let's say, print A here. You can see it's telling us dead code. If you return something, you cannot write another code after it. So if you want to write a block of code, you have to write it before the return statement. So you can see. So if I try to print A after the return statement, it's not going to allow. So it's going to check 50 here. 50 is greater than B. Then it returns A. It's not going to bother running the else block. Then it runs. It checks. Is there any other block of code here? Oh, there is no block of code. It checks. Then it runs. Oh, now we are done with the function. Now we are returning A. We are returning A because A is 50 here. So now this is what this function is going to evaluate. It's going to return. So it's going to return the number 50. So that's why var n now is 50. And if we print n, that's why it's giving us 50. I hope you get. I want to try to debug the code so you can follow. You can follow it. Let's say block by block. Hold on. Let me try to debug it. I know I've not shown you something like this. Well, our time is almost over. So after the If the Zoom meeting logs you out, please just join again. Yeah, I'm trying to debug. Hold on. Please give me a moment. Let's continue. I don't think I can set. I don't think I can set this one up. So you can get what the max function does. It's just taking two numbers and it's returning the largest. Alternatively, you can do the same for the mean to get the minimum. Mean, it's A, it's B. So we can basically just write the same thing. We can say if, now we are doing the inverse. We check if A is less than B, return A, right? Because that means A is smaller, right? Then else, you can say return B. So we can write this if statement a lot of ways. So let's think of another way. Can even check if B is greater than A. That means B, you know B is greater than A, right? That means we can return A. Or else can return B. So we can even write it the same way. But I don't want to confuse you. It's left to your taste, the way you reason about the logic. So we can check if A is less than B. That means A is smaller, right? That means this expression evaluates to true. Then it returns A. But then if it checks, is A less than B? Now, if he sees that this expression evaluates to false, does not bother entering this block of code. It runs the next block, which is the else block. Now it runs this block, and then it returns B as the smallest. So now, let's do the same for, let's call it G. Remember, we have to invoke the function. So we are invoking min. So let's call G. Now, if we call G, we are expecting G to print out 34 because 34 is the smallest, right? As you can see, it's printing out 34. So now, no matter what number we specify 5,000, specify this amount, this number, any random number, it's still going to run the code. So you can see it's returning the smallest, right? Because we are looking for the mean. So if you can imagine now, we can use this min function, or max function anywhere in our code. So you can see. So we don't need to check. If we want to check if two numbers, we want to check the largest between two numbers in our code, anywhere in our code. We don't need to keep writing this if statement. We can just simply call the function and supply those two numbers. So I hope you are getting why we need this function. Hopefully you are kind of you are gaining, even if it's just a little bit, you should know why we need function and how to declare functions and how to invoke functions. Hello, can you hear me? Hello, I hope I've not lost you guys.
Yes.
All right. Now I mentioned that if we are going to write a little bit of a small program, a CLI. This code we want to write now is just a mini project. It's one of the projects I said we are going to write in this bootcamp. So what this code, this program is just going to do is a terminal app like this. You know, this is our terminal. It's a CLI. So it's a terminal app. It's just like a game. We are going to tell that to generate a random number for us. And then we are going to tell the user to just supply any number. So now we're now going to check if the number the user supplied is higher than the number that's, I hope you can follow. If you are confused, let me know. So we are going to check if the number that the user supplied is greater than that that number that generated for us. And now we're going to print out that, oh, the number you supplied is too high. But if the number is lower than what that's generated for us, we're going to tell the user, oh, sorry, try again. The number is too low. But then if the user gets the answer correctly, now we can exit the app. We can tell the user, congratulations, you got the number successfully. Then we are going to exit the app. But if the user doesn't get the answer correctly, we are still going to keep running the app. So you should think about loop. You know, we talked about loop statements a while ago. So you should think about looping. So we're going to keep running the block of code until the user gets the answer correctly. So now to do this, we are going to type. Now we are going to get our hands dirty. So what I want you to do is, hold on. Give me a moment. What should we name the project now? Okay. Now, if you can see my cursor, create a new file here with this icon, new file, call it guess_game.dat. If you've done that, let me know, please. Hello, please, I need response.
I've done that.
All right. We are 5. I'm sorry. Yeah, we are 5. Just one has responded.
Yes.
All right. Who else are we waiting for? Yeah, the meeting is going to close soon. So you can join again with us. And please don't take time, please. Let's join as soon as possible. Sorry, who else are we waiting for? Can I continue? Am I free to continue? Miss Treasure, can we continue?
Yes, please continue.
All right, good. So let's just wait for this session to end by itself. Then we can join again. All right. So right now I'm not just going to teach you syntax, how to write that program. You need to think like a programmer too. So if you want to write a program, don't think of your program as like you just want to write code. You just want to write code. No, think about. So what I was saying was that you should think about your code like you are trying to solve like a problem. Not like you just want to write code. It's not like you just start typing. That's not how, if you watch all those movies, you see hackers, they will wear hoodie. Now they will face their computer, start typing. Blah, blah, blah. That's a lie. That's not how development works. So it takes some serious meditation, sitting down. You write on paper, on a sheet of paper, write what you are trying to solve before you start to type. So that's how we write applications as developers. It's not that everything just comes naturally. If you are trying to solve an issue, if you are trying to solve a problem with code, you sit down, you think about the problem, you break it down into smaller parts, and then you try to solve the smaller parts until everything gets solved. I hope you are following. Yeah. Hello. Hello.
Yes, we can hear you.
Yes.
All right.
No.
All right. So, okay, you are seeing my screen, right? Are you seeing my screen?
Yes, yes.
All right.
Yes.
So now, I said, so let's break down our problem into smaller units.
This KRT.
Exactly. So the first thing to do.
Hey, that's what I do.
So the first thing to do is we generate a random number.
No mercy.
Hold on.
No. Don't you have anyone?
The second thing, we ask the user to input their guess, right? You know, we want to compare the random number that the program is generating for us and whatever the user inputs. So we want to do that, and then we use that to decide if the user has won the game or not. So now we are asking the user to input their guess. Now the third one.
Extraction 2.
Hold on.
Are you sure? I need to this is 2. Yeah, no that. Just pay the salary.
Now the third one, we check if the user's input is equal to the generated number.
Yeah.
So let's say the generated number. Sorry, someone is disturbing. Sorry, Celine. All right.
Sorry, didn't know my microphone was on.
So we check if the user's input is equal to the generated number. Let's say the generated number is 56. So this is what I'm saying. So let's say the generated number is 56. Now, and let's say the user inputs 90. Now, if the user inputs 90, we have to tell the user that, oh, sorry, the number you inputted was too high. Please try again. Now, the user inputs, let's say 40. We say, oh, sorry, the number you inputted is too low. Please try again. Now, we keep prompting the user that same message. And we don't quit the game until the user gets the correct answer. Now, if the user gets the correct guessed number, the random number, now we are going to tell the user, yeah, yes, you won. She get. We tell the user now, yes, you won. And then only then we can now quit the game. So that's the program we want to write. Now we check if the user's input is equal to the generated number. Hold on. Now we check if the user's input is equal to the generated random number, then the user won the game. Hold on. Sorry. We check again. If it is lower, then we prompt the user that it is too low, and then we replay the game. Just like I've explained when I used 56 and stuff. Now, if it is too high, if it is higher, we prompt the user that it's high. Sorry, it's high, and then we replay the game. So we keep replaying the game until the user gets the correct answer. So you should be thinking about while loop here. You should be thinking about loop. Remember, I said we use loops for repetition to repeat something for as long as we want. So now think about the problem like this. We generate a random number, then we ask the user to input their guess, and then we check if the user's input is equal to the random number. Now, if the user's input is equal to the random, oh wow. If the user's input is equal to the random number, then the user won the game. We quit the game. But if the user's input is lower, we tell the user, your input is too low. Please play again. If the user's input is too high, We tell the user your input is too high, we play the game. So with that, we can start with our application. Remember our void main. Our code has to be in the void main. So now we can start. I don't just want to start typing and all that. You have to type along. Sorry, you have to type along. Now, I don't want to just start typing everything like I know what I'm doing. I want to write the code like we are solving the problem together. So you should know if you are trying to write the code for your own problem. So now the first thing, now we want to tell the application that yes, this is a game. This is just to beautify. All right. You can print welcome to the investing game. Then we can duplicate this one. So now, hold on. If we go to our terminal and then we run, remember we have to run it with the name of the application. I have to type that run guess game dot start. So you can see on your terminal, you can see saying welcome to the guess game. So we've started our mini application now. So if you want me to wait for you to type this, I'm waiting. Tell me when you're done. I hope you're there. Hello, guys.
Hello.
All right. So I'm waiting. You can type this.
Yes, I'm working on it.
All right. So if you run the application, it should give you whatever you are printing. So you're just telling the user, welcome to the guess game. So that's the beginning. Please signify if you are done.
Yeah, I'm done.
All right. Selim, how about you?
Sorry, my network was bad, so I listened for quite a while. I'll type it now.
So I'm sharing my Chrome.
Sorry, what are we supposed to type first? So I'm supposed to first print a welcome message for the people in the game. Abi?
So you can see my screen now. We are just welcoming the user to the game. So you can see in my void main, I just wrote some couple of print statements just to welcome the user. In your terminal, you can run the program by just typing that run guess underscore game dot stat, the name of your file. Yeah, that run and then the name of the file, and then click enter. So it's just going to print out whatever we told it to print. So Selim, we're waiting for you. All left. All right, Selim, are you done?
I'm almost done.
Miss Toby, are you done? We are not following along. You need to type. It's not just that you'll be watching and watching. You need to build out your muscle memory. You need to type.
I'm typing.
All right.
Yeah.
So now we have started getting our hands dirty. So if you've done that, the next thing we wrote on our to-do list, we said we want to generate a random number. And then now we will now think, oh, how do we generate random numbers in that. Now we can Google that. Let me share my my Chrome. Hold on. So we can Google generate random numbers in that. You can see. Let's click on Stack Overflow. You are going to be referencing this site in your career, this Stack Overflow site. So now we asked, how do I generate random numbers in that? So you can see here, we have this tick mark. That means this answer is correct. So we don't need this. Yeah, to generate random number, we use a library that gets we use that library. That is the math library. It's given to us by that for free. Now, let me share my. All right. So when I googled the question, this was what it was giving us. This was the answer. It said, let me copy and paste. It said we have to use var range new random. Forget about this. So now it's saying the function random isn't defined. Try importing the library. So this brings us to the next thing we want to talk about. Now we can import a functionality. Let's say we want to import a function. Okay, and let me comment this out. You know, we have this file. All these files, they are in the same folder, which is the data tutorial folder. So now, you know, we have this max function in this file, right? So now we can use this max function in this other file. You know, this is a new file. This guest game.dat. You can use it by importing. We call it imports.
What did you say? You didn't put the X on? Yeah,
see what it's saying. Hold on. Let me take this away. See, the function max isn't defined. Try importing library that defines max. You can read the error message. So what the error is telling us is that we don't have this function defined in this file. So I forgot to mention earlier, a file like this, a file in that, we call it a library. This file right now is a library. So this data tutorials contains libraries. So collection is a library, control flow is a library, all these libraries. As long as it's a .dat file, .dat is a library. So it's telling us this function max, the function called max, is not defined. So what we need to do is we need to find a library that has this max function defined. So where did we define it? We defined it in the functions library here. As you can remember, when we were talking about functions, we have this max in the function library. So to import it, we can type imports functions.dat. So we are importing the functions.dat file. So you can see, we can use the function here. So you can see we are using that max as if the declaration of the function was in this library. So that's what we use the import statement for. So you can see by importing this function.dat, so we can use the max function that is declared in the function library. So you can see the max is declared here. So we want to use it here. We need to import that library. So that was what happened when we wanted to use the random. So random is not a function, it's an how do I is a class, yes. Random is a class. So the random class is not defined anywhere here. We are not defining any random class here. So we want to use it from the math library. So that has a library, a math library that it stores all these math operations and all. So we want to use this random class. We need to import. So you can just write imports. I see import math, that and then math. You can do that. Or another way, because all those extensions we were installing earlier. These we are getting to the part where we are using them one by one. So yeah, you can just click anywhere on that random. You don't need to highlight it. Then you can just press Control and then dot. Control plus dots. Then it should bring out all this intelligence. Import library that.math. Then you can click this one, this import. So you can see it automatically imports it for you. Now you can use that random class in this library. Hold on. I hope I'm confusing you. I hope you get that. If you want me to come back, you can. Hello.
Sorry, you said
I'm good on my end.
Okay. So that's what we use.
I was trying to confirm something. You said control what? Control what did
Control
you press while
full stop. Control and full stop. Control and dots, full stop. Or that random. So you should prompt. Okay, let me do it again. If I click control and full stop, it should bring out this import library that.math. So the same way that time we're using that max function. So okay, let's apply it an integer here, another integer here. So hold on. There's something I did mention. We have, we defined our own max here. The math library, the math library also has a function called max. So I mentioned that that is open source. So you can just dig in and find out how a code is implemented. So let's see how they implemented their own max. You can just click Control and hover around that, whatever you want to check. Hover around it and just use your mouse to click on it. It should take you to a file. You see, it's taking me to that math.dat library where that max is defined. So I know this will look like jargons to you, but this is how they define their own max function. So now, if you don't want their own max, the math library has its own max function, but we want to use the function from this our own function library. So you can just put an alias on this library, on this math library, and put an alias like math as math. You can use the as math. So if you want to use any function from this math library now, we now have to use that, the name we specified for it, then dots. See, math dots. You can see now we can use math.random here. So now we are telling you that this random is from this math library, but we are supplying it a name, so an alias. So here you can see this will not work until we put that math dots here, but it's because we don't want to use the math library, the max from the math library. We don't want to use it. We want to use the max from this functions library. So we can control click on this one too. So you can see it's giving us that.math. Hold on. If you scroll down, you see import library functions .dat. So this is the one. This is our own library. This is where our own max function is defined. So you can see. So if you check, we are importing the math library as math, and then we are importing the functions library, the one we wrote here. So now we can use our own max. We can use their own. So this is the crazy part. We can, if we use our own max, if we use their own max, it's still the same thing. Let me give you an instance. Remember this max, this one. Okay, let's give it an alias too. Let's see as fn, because it's our own fn. So we want to use it here. We'll see fn.max. So now we also have math.max. Remember. So they are doing the same thing. See, this one is the one that this marks is the one given to us by the DAT developers from the DAT library, from the math library. See. But this one is the one we defined ourselves in the functions library. See, it's this one that we did, the function library. So if we print, let's see, okay. Let's print. Let's take this one. Put it here. Let's take this one. Put it here. You can see we are supplying the same numbers, but we are using different functions. I'm telling you that we implemented our own marks, and we are using their own marks too. So it's giving us, it's supposed to be the same thing, but they are basically doing the same function. So if we run this code now, it's going to print that welcome message that we did. But you can see this one is from the math library, CC4, and this one is from the one that we defined ourselves. The math library too has its own main. It has its own main. You know, in our own library, so we defined our own main. So if you print main, you print it, it's going to run and give us 3 and 3. So you can see. So that's just all about import statements. For now, that's all you need to know about import statements. So let's do away with that function library, the function library, and let's do it with the alias. Then we don't need to use math dot here again. So now this random is defined in this math library. You can see. So now this is just to generate a random number. Now we want to generate. We don't just want to generate. Numbers is like infinity. It's uncountable. So let's just give it a range. We just want to give it a range that we don't want you to guess between 1 and 100. Okay, if you want the random, we want this class to do that for us, there is a method we can call on it. We can say dot next int 101 plus 1. Don't bother yourself too much about this line. Just know that what this line is doing is that it's generating a number between 1 and 100. So you get, this is what this line is going to do. So whatever that is evaluating, so whatever it is returning, we are storing it in a variable called range. So let's see if we are really generating a random number.
Sorry, Jami, please.
All right.
You said the number is generating between 1 and 100.
Yes.
But
yes.
so we didn't indicate 1 here.
Where? Yeah, if we don't indicate anything, it's going to start from 0. This random number is going to start.
So do you mean that it's generating from 100 upward?
No. What I meant was it's going to start from the range we are specifying between 0. Normally, if we don't use this all these ones, what this is going to do is going to generate from 0 to any number. So it doesn't have like a fixed point. It doesn't have an ending point. It can generate 10,000, 10 million and something. But we want to give it like a constraint that just want you to, yes, a limit. We want you to stop at 100. Just generate a random number and pick a random number between 0 and 100. But we want it to start from 1. We don't want it to start from 0. That's why I'm using this +1 here. So I'm just saying, don't bother yourself too much about this syntax. Just know this line of code here, from here to here, this expression is just going to generate random number between 1 and 100. If we had used 100 here instead of 101, 100 is not inclusive. It's just going to generate between 1 and 99. So that's why I'm using 101 here. So it should reach that 100. I'm using +1 here because we want it to start from 1, not from 0. So it's starting from 1 to 100. So generate any random number from 1 to 100. So let's print whatever the range is. Let's print it. For now, let's comment this one out so to not clutter our terminal. There, let me clear my terminal. So we are printing range, right? Let's run that. Yes. So you can see right now, range is printing 96, right? We can keep printing range. It will keep generating random. See, now it's printing 80. Now it's printing 70.
Okay.
Now it's printing 77. So it's generating any
understand.
random number between 1 and 1000. So now this is the game. The game is that once the user to input any number, she gets. We are not going to show the user the random number yet. I'm just going to tell the user to input any number. Now we're now going to compare that number that the user is giving us. We're going to compare it with this random number that we generated. I'm going to check if that number that the user inputs is equal to that random number, then the user wins. But if the user doesn't win, we are going to keep playing the game until the user wins. I hope you can get it now. Yeah.
Yes, I can understand now.
All right. So now that's what this line is basically doing. It's just, so I'm sorry if I'm rushing, it's because of the time. We have overused our time. It's just going to generate a random number between 1 to 100. Sorry, 1 and 100. All right, so we can continue now. So now we have done our first task. We are generating a random number. So we can continue. For the others, if you are not clear enough, I can go back. All right, we can continue. So now we want to ask. Hello?
Huh?
Can I continue?
Yeah.
All right. We want to ask the user to input their guess, to give us their inputs. Now, you know, I told you as a developer, Google is your friend. If you don't know how to do something, you have to Google. Now we want to ask Google now, how do you get inputs from the terminal? Let's go and ask Google. I'll share my Chrome now. Sorry. All right. So you know, the previous time I asked Google, how do we generate a random number? You can see this is where I saw the code. See, it's giving us var range is equals to random. So if you keep scrolling, you see other people's implementation and all that. Now I want to ask, how do we take inputs from the terminal? You see that terminal inputs. You can see it's giving us, how do I read console inputs? That. So we click on it. You can see it's still taking me to Stack Overflow. I mentioned this Stack Overflow, you are going to be using it a lot in your career. You are going to be using Stack Overflow. You can see the code they are telling us. They say we have to use the IO. What IO means is input output. We have to use the IO library. We have to import the IO library. Then we have to call, because this stdin is from the IO library. We are calling the stdin. Then we are using the readline sync method on it, readline sync. And then this UTF-8 is just basically just parsing, PARSE, is passing the, because whatever you input to terminal is not English. It's not going to be read like as English. So we are just telling it to encode it back to English here. So UTF-8 to encode it to English. So that's what this line is. So this line is just getting the inputs from the user. So that's what this line, and then we are storing it, we are catching. Remember I said if you just use a function or a method, and if the method or function is returning something, so you get, if it's returning something, you have to catch it, you have to store it somewhere, or else it's just floating around in memory. So you have to capture it. So here we are capturing it in a variable called the line. So you get, we capture it in a variable called line. Something I failed to mention, we are using the convert library. That's what we use to convert whatever the user types back to English. So we are using these two libraries. So what I want to do now, let's copy this line of code. Let's copy this line of code. Let me share my screen again. So I copy that line of code. See it now. So you see, it's giving us error because undefined name, UTF-8, undefined name, and blah, blah, blah. So we need to, like I did before, we need to import that library, control and dots on this. So you see saying import library.io. So we click on it. It's importing IO. Remember, we use that math library to import to use the random generator class. Now we're using the IO library to read input from the user. Now to encode it, to pass it to string, to readable English, we are using UTF-8. And UTF-8 too is not defined here. It's defined in another library. We control and click. It's defined in the convert library. You see, that converts. We're importing this library too. So all those extensions we were installing the other time, we have started using it now. Because normally you would have had to type all this on your own, import, blah, blah, blah. But because of all this extension, you can just click on whatever you want and then type, click on control and then dots to prompt whatever it is you want to use. So now that's what this line is for. So let's name this another variable. Let's name it input, because that's what the user is inputting, right? I hope I've not lost you guys. Hello.
Yep.
All right.
I
So
can hear you.
all right. So if you hover around inputs, you can see it's saying a nullable string. Remember when I was teaching about null safety, I said you have string and then you have nullable string. The reason why this is returning a nullable string is because if in your terminal, if you prompt a user to input something and the user doesn't input anything, just press enter. That's null automatically. That means null is going to restore. That's why here stdin is returning a nullable string, not an ordinary string. So that's why if you want to print input now, if we print input, for instance, let me show you what I was talking about. Let's run it. Hold on. Hold on, let me comment out this. So if you check my terminal now, you know I'm running the code. See, it's not normally if it has finished running, it will bring out this thing again at the bottom. But here, it's waiting for me to enter something. Here, it's waiting for me to enter something. Imagine I don't enter anything. See, because I'm printing, it's not printing anything because I didn't enter anything. But if I enter something, you know, it didn't print anything because that was null the other time. If I enter, let's see, Jamil. See now, it's now printing Jamil. Okay, so even make this visible enough. Let's see. I then the input, right? So if you run this, it's waiting for me to input something. Let's see, Jamil. So you see, it's now printing out Jamil. You know, it was waiting for my input in the terminal. Remember, the code was already running. So you know, I mentioned runtime and compile time the other time. So now the code is already running. So now we are giving it Jamil when it is running in runtime. Now it's now printing Jamil. Let's try something. Let's see. I didn't input anything. I just print. So it's printing nothing. So it's basically input is basically null here, null. That's why stdin is returning a nullable string. All right. So now we know stdin is returning a nullable string, but you know, in our code, right, we need a number, because if you want to compare whatever this random, you see range is returning an integer, right? We want to compare whatever this random generators is giving us. I want to compare it to whatever the user inputs. I remember we said the user, whatever the user inputs here is basically going to return a string. Okay. Even if I say I3, so you are not expected to know everything. She gets Google is your friend as a developer. You don't need to cram that. You don't need to cram code like that random generator now. You don't need to cram it. A simple Google will help you. Just go and Google how you get random numbers in that. Then you can copy the code. You copy code a lot too. So all you need to know is just you want to solve a problem. So you don't need to know how to generate random number and all that. Just know that you want to implement something. Is that okay?
All right.
All right. So you don't need to
Yes.
cram this one. You don't need to cram. Just you can. Okay. Let me share my Google now. So you can just simply Google for how to generate random number from a range. Within a range. It's because me, I have what did they call it? Grepper here. It's giving me, I have the result here already. But for you, you don't have something like this. You just have to check through the results. Mostly you'll be checking Stack Overflow. See. Here. It's the same thing here. Random.nextInt. That was what we used the other time. See here. Here it's saying random.nextInt 90 plus 10. This is basically the same thing we did. He's using random here because he has already instantiated the.
Sorry, so this particular one now, that's plus 10. It will be in sequence of 10. Like 10, 20.
It will be between, hold on. It will be between 10 to 89. Sorry, 10 to 90. 90 exclusive. It won't print out 90. It will stop at 89. It will start generating the number from 10. So it will discard 0, 1, 2, 3, 4, 5, 6. So whenever it wants to generate a random number, it starts from 10 till it reaches 89. It does not get to 90. So if you want to generate to 90, you have to use 91.
Okay, but sorry, my own actually generated 101. Using that same line. The first number that generated 101 for me was 101. Yes.
Are you sure?
Yes, that was the first thing that my own generated.
Oh, hold on. From 10 up to 99 included. What was the same? 0 up to 99. I'll get back to you on that. That's quite confusing. All right.
Okay.
I'll get back to you on that. So as I was saying, you don't expect a developer to know everything. You're not expected to cram things. All you need to know, knowing how to Google is part of your job as a developer. You have to know how to Google. You have to know how to search for answers. If you are going for what do you call it? If you are going for an interview, like a technical interview, you have access to Google. You can Google. In a technical interview, you can Google. You can to solve an issue, to solve a problem they give you. All right. Let me share my All right. So I said this is the problem here. This random number generator is generating an integer, right? And this one is generating a string. Even if we input, hold on, I was trying to input something the other time. Let me run it again. So we want to input a number. Let's input 4. We are inputting a number here, but automatically 4 turns to a string because here we are encoding it to UTF-8. Whatever, even if we input Boolean, it's going to get converted to a string here. So input here is now a string. So 4 is a string. We are saying I4. So 4 is now a string. Now imagine we want to check. Imagine you want to check range is greater than input. It's not going to allow us. Why? Because input is of type string. See, argument type string. It's not even a normal string. It's a nullable string. Can't be assigned to a parameter type num. So when I said we want to use this relational operator, we have to compare. If you are using greater than or less than, we have to use a number. Okay, we have to use either integers or double. We can say a string. Can you even reason about it? Can you say is string? Let's say this one is a string range is greater than. So you can see it's not even thinkable. Do you know how can you check if a string is greater than another string or less than another string? What you can do is you can check if they are equal, right? But you cannot check if it is greater or less than. So that's why here, we have range. Range is an integer. We cannot check range and input because input is of type string. Is of type string. And it's not even a normal string, it's a nullable string. So now if you think about this, like if you have a string, like a number that is inside quotes, that number is a string. Like, let's see, var n is equals to 4. This 4 is an integer, right? This n is an integer. But then if we put quotes here, it becomes a string. This 4 becomes a string. But there should be a way. You should think about it. There should be a way where we can convert this string into an integer. Let's Google. Hold on. Where is my Google? Give me a moment. Hold on. So we want to check how can you convert a string to an integer in that. Convert string to int in that. So you see, we want to use Stack Overflow here. How do I pass? So this English parse. What parse means is just to convert something. So you get to parse something means to convert something. So you want to pass a string into a number with that. So you can see here, he's saying we have to use this method, and this method is on the int class. I said every type in that inherits from object class. So this integer now, it has a pass method, int.pass. So you provide it a string. So you see, this is a string. You provide a string. Now it passes this string back into a number. So let's try this. Let's copy this. So we can decrypt it ourselves. I'm teaching you how to Google too. So let's discard this. This is what I copied from this thing. He said var my int.pass. You see, is giving it a string. You can if you check my int now, my int is of type int. You see. Remember, if you don't pass it, my int is string. But now we are passing it. It's giving us integers because it has already passed it. So now we can pass this n to this n by saying int dot pass. So you can see now n is now an integer. But there's a catch here. There's a catch. For instance, this is my int. We are passing 1, 2, 3, 4, but it's inside string. It's inside quotes. Imagine we used a normal string, hello. You can kind of see the problem here. We are trying to pass, if you hover around this, we are trying to pass, and we are trying to pass integers that is inside string. But here we are supplying it string characters, right? So it's expecting integers inside string, and we are passing it normal characters. So you can see there is an issue. If you try to print, what do you want this hello to pass to? So you can see there's an issue. Let's print my int first. It's going to return, it's going to cause an error. Oh, I've forgotten that we are using this input stuff. Let's comment this one out. So you can see it's giving us error. You see, invalid values, blah 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 blah. You see, he's pointing to that yellow. Pointing to that yellow that he's expecting integers here, and you're giving me normal characters. So if you had said, let's say 324, right? Let's run it. There will be no errors. So you see, it's printing 324 now. So you have to supply an integer that is inside quotes if you want to pass. So with that in mind, you know, we said input returns a string, and we want to pass it to an integer. So what we can do now, we can create another variable here. Let's call it passed input, and call pass int. No, int. Sorry. We can call int.pass and supply inputs. Hi. I'm sorry. So we are using int.pass and we're passing input. It's not going to allow input because, you know, we said input is nullable, right? But there's a way around this. Pass is expecting a non-nullable string, right? A non-nullable string. But we are supplying a nullable string. But there's a way to tell that look, forget, I know that this is not going to be null. Forget that this is nullable. I know the user is never going to supply null. So there's a way to tell that about that. So you use this exclamation mark at the end of the input. So you are telling that I know this user is going to supply something. But there's an issue. If you can ask what the issue is. The issue is that now you are telling that I know the user is never going to supply null. Null meaning nothing. I know the user is still going to supply something. So, but if the user goes ahead to supply nothing, this statement here is going to cause issue to your code. Your code is going to fail here. Let's try it. Hold on. Let me comment this one out. So this time around, so you can see it's waiting for me to input something. Now if I click enter, you can see the error message. See, for invalid number as character, because we are not supplying anything as input here. Input becomes null. So that's why there is an issue. But if you had supplied something, if you have questions, ask me. If you had supplied something, let's see, you supplied again, another issue again. There's another issue. If you had supplied a string, like I mentioned that time, if you had supplied hello, gives us another error. Jeez. But then all it needs is numbers. Let's say 456. Now it says I456. So you get. I want to digress a little bit. I want to talk about how you can catch all this kind of error. So if you don't want your application to fail because of all this error, you don't know what the user is doing. If the user doesn't supply anything and press enter, your program will fail. If the user supplies the normal string, your program will fail. So all this depends on the user's input. So there is a way to kind of catch all these loopholes. So your program will crash. There's a way to catch all these things. So we call them. We use this thing called try catch block. Try catch. So we use try catch block. So this is how we use try catch block. Whatever you want to try and catch, you put it in the try. You can see this is a try block and this is a catch block. What this is doing is that whatever code you want to run, put it in your try block. But if there's an error, now it's going to catch the error. So whatever you want your code to do when there's an error, you put it in your catch error, for instance. So now your program is never going to fail because now you're catching the error. Let's carry our code here. We put our code here, right? Now, we are being supplied with this E. This E is the error that gets caught whenever this code fails. For instance, let's print what this E is. Let's print E. So we want to force this code to fail. So now if we don't supply anything in our terminal, if you just press enter, see, it's not failing. It's just telling us format exception, invalid number. So you can see we are catching the error now. So now this catch is just to catch the error. If there's an error, it's going to catch the error. So we use try and catch. So I'm just printing here. Normal, if we get to Flutter and a network request and all that, we will learn how to catch errors and how to deal with caught errors automatically. But now let's just leave it in our try and catch block. So here, let me come again. The first thing we did, we generated random numbers between 1 to 100. Here we are receiving inputs from the user and we are passing it into a string. The input has to be integers because we want to compare it with the random generated number. So here, that's what we are doing here. We are that input that the user supplies, we are passing it to an integer, and then we are storing it in a variable. So now this is the input that we want to use. The real input that we want to use is this passed input. So now here we can now check. If now we can use our if statement here. If range is equal to, remember, I said you want to check if something is equal to something. Use double equals to sign. 1 is for assignment. Hello, I hope I have not lost you guys. We're almost done. Sorry, bear with me. Hello? Hello?
We can hear you.
All right.
Yes, we can hear you.
All right. So, I remember I said 1 equal to sign is to assign something like this one here. We are assigning whatever this evaluates to. We are assigning it to a variable called range. But here we don't want to assign. We want to check if it's equal to the past int. If it's equal to the past int, you get. I want it to print congratulations. You won. That's for if it is equal. Now I want to check else if the range is greater than past. Sorry, let me. So I want to check if past inputs, the inputs that we passed already, if it is greater than the range. If it's greater than the range, then we want to print inputs to I, try again, right? That's if the past input is greater than the range. And then the next one is, we can use else if, but this one is for catch up because we know the next one is if the past input is less than range. That's what the else is for. Is a catch up block because we know there is no other check there's no other thing we want to check for again. So we can use the else. Alternatively, we can use else if too. We can use else if past input is less than range. We can print input to low. Try again. Because we've exhausted any way possible, we can get rid of that else if, or for readability, if you want, you can get rid. So we are saying if the range is equal to the past input, then that means the user will. Else, if the past input is greater than the range, that means that the input is too high. We are telling the user, sorry, input too high, try again. Else, if the input is too low, we are telling the user, sorry, input too low. So to kind of follow this, let's print what range is and what input is. Print, let's see, range is random is range. And then let's print past inputs. Let's see. Input. So now we just want to see how the code is run. We want to see what ranges and what past input is. Now let's run this program. So it's waiting for us to give an input. So let's see 45. So you can see random is 52. Input is 45. Sorry, input too low. You can see because 45 is lower than 52. Abi. That's why I'm saying sorry, input too low. It's now telling us try again. To try again, we have to keep running the program again. We have to keep running and running and running and running. So instead of us doing all this, let me play the game again. 34. You can see random is 65. Input is 34. Sorry, input too low. Let me play it one more time. Let me give it 90. You can see random is 37. Input is 90. Sorry, input too high. So instead of trying to run the code over and over again, we can have there's something we call a while loop. While loop, what is used for is that it's going to keep running that same program until you tell it to stop, until an expression evaluates to false. So now to run a while loop, we need to keep track of if we've won the game. So we create a variable called var is 1. So in the that conversion, if you want to write a Boolean, we use this is keyword, like not a keyword, like we append is to our variable. Like I want to say is 1, is lost, is you get it. So say is 1. Let's say it starts from false. From beginning, the user has not 1 now. So from beginning, the user has not 1. Is 1 is false from beginning. So now I want to put this thing, this whole if statement in a while loop. Yeah. Hold on. Okay. Sorry, give me a moment. All right. Hold on. Not to clutter our code. Let's get rid of the try and catch block. That was just to show you how to catch exceptions, right? So this is how to write a while loop. You see, while you know, all these extensions I was telling you about, this is where they come in handy. You know, when I typed while, see, it's giving me this IntelliSense. So I'm going to pick this one that has this kind of square. If I click it, see, it's going to finish the block for me. It's just expecting me to provide an evaluation. That's to provide an expression that evaluates to a Boolean. So remember when I said if statement needs a Boolean, this while statement too, it expects a Boolean. So this range is going to evaluate to Boolean, right? It's going to check if range is equals to past input. So this is going to evaluate to true or false. So while parenthesis too, it expects an expression that evaluates to a Boolean. So now I want to check if is 1. I want to check if is 1 is false. So I want to check if the user has not won the game. If the user has not won the game, we want to keep running the program every time if the user has not won the game. So we want to carry all this block of code. This here where we are generating random number now. Sorry, where we are passing the random number now. We put it inside the while block. So you know where we are generating the random number. This one should be outside the while statement, because if you put it in the while statement, the random number is going to keep changing every time we keep playing. So and if you do that, hold on, I'll show you that. I'll show you. If we put it inside the while statement, the while block. Hold on. All this should be in the while block. So what we're saying is, while is 1 is false. While is 1 is false, we should keep running this program over and over again. I remember I said if you're using while loop, you have to give it like a terminating expression where we have to supply when it should terminate, or else this program is going to run forever. So when should this program terminate? If you think about it, when should this while loop terminate? If you think about it, it should be when the user wins. It should be when the user wins the program. So here in this, if range is equals to passive input, we need to terminate we need to convert is 1 to true here. So we need to say, right? We need to say is 1 is now equals to true. So that's what we should do here. So now here, if range is equals to past inputs, we are going to change is 1 to true. Now it runs the program, it checks range is equals to past input. Oh, yes, it is true. Now is 1 turns to true. It prints congratulations, you won. It doesn't bother running all this else block. It goes down and check, is there any other block to run? No. Then it goes, check the while, because it checks the while statement again. Now it sees, now is 1 is now true. So it's going to terminate this while block. It's not going to run anything inside this while block again, because is 1 has now turned to true. But because if range is not equal to past input here, it's going to run this else, it's going to run here. It's going to check again, go. Is 1 is still false, it's going to run. Check. Is 1 is still is range is equal to past, is 1 is still false, go. Is 1 is still false, go. But then if you get the answer, now is 1 is true, checks. While is 1. Now is 1 is expecting is 1 to be false here, and this 1 has turned to true. So it's going to exit this while loop. So let's take this one out. So that's one. So it's waiting for us to input, give an input. We say for, you see, sorry, input too low, try again. You see, before we use the while loop, the program exited. We were supposed to we are supposed to run the program again. But here, because of the while loop, it's not exiting. It's waiting for us to get the answer. Let's say 45. See, random is 32. Input is 45. Let's see, 56. It's still running. Random is 32. Input is 56. Now let's give the correct answer, which is 32. Congratulations, you won. Now it exits the program. So to make the game interesting, let's get rid of this print statement, so we don't see what random or this one is. And then let's uncomment this one out. So it's welcoming us to the game. And then we need to prompt the user that should give us, should print, should input something. So here we print guess the number, and then we run this code. So let me try to run this. We're almost out of time. And then we'll see, it's telling us welcome to the guessing game. Now guess the number. Let's supply 34. See, 34. Sorry, input too low. Try again. Let's supply 45. Sorry, input too low. Try again. So let's keep going at 56. Sorry, input too low. Try again. Let's say 78. Sorry, input too low. Let's say 89. Input too low. Voila. Let's say 98. 98 input too low. Let's say 99. Now, so the guess was 99. So now we won. Let's try to play the game again. So welcome to the guess game. Let's see 53. Sorry, input too low. Why is it giving us a high number? Input too low again, 98. Input too high. So 98 is too high. Let's see 88. It's too high. Let's see 70. Too low. So it's between 70 and 88. Let's see 78. Too low. Let's see 81. Sorry, 83. 2i. So let's say 81. 2i. So definitely should be 82. Oh, I guess what? 2i. So sorry, let's try 80. Still 2i. So the answer was 79. All right. I know this is a lot to take in. You are not going to get it once. That's why I'm recording this session. So you can just try to watch the session. I'll try to post it on YouTube. I'll try to upload it on YouTube. So you can watch maybe today or tonight or tomorrow. So you can watch it again. You can watch it even 2 times. So watch it again. After watching it, try to solve it yourself. Try to do it yourself. So what I meant by doing it yourself, you write down the problems you are trying to solve. You can even go to Google to ask, like I did, how do we get random numbers from this range? How do we get input from user? How do we pass string to integers? You can do all that. So just kind of play with all that, and then yeah. So the session will soon be over. Do you have any questions before we end the session? Hello?
No, no question. Just how did you add the emoji?
Yeah?
The
How did I
emoji
what?
you use. Add the emoji.
How do I add?
The emoji you use.
Oh, yeah. I have a, what do you call it? An extension for that. I forgot now I did it. I have an extension that I can just type colon, let's see, flower or something. I can't remember. So I have an extension for this. I think on Windows, I don't know. Yeah, on Windows, you can type the window key and dots. It should bring out this emoji box. So you can use any emoji. So you can see. Try it. You can try it yourself. Window and full stop. You can see it. Abi? Yes, Ellen. Hello.
Yes, I can see.
All right. So no problem. So you can rewatch the session after I uploaded this. So, Mr. Alalekon, is there any question?
Sorry, window, what did you call it?
Window and dots. Window and full stop, right?
Okay.